Well, hello and welcome to DevSecCon Germany. It is a part of the DevSecCon global community. It's an inclusive community that educates and enables developers on application security. Coming up today, we'll be joined by Rex to talk about evaluating security in a Go-centric DevOps environment. Before we dive into that, I just want to quickly introduce ourselves. I'm Seb. I'm a tech specialist at Sneak and co-leading the German chapter for DevSecCon Germany. And I'm joined by Ardit.
Yep, and I'm Arid, security specialist at ESET Germany. For anyone watching right now, head over to the YouTube channel to interact with our speaker, Rex, and ask questions or feel free to share any comments. Afterwards, the Discord server would be the best place to interact with our speakers and fellow community members. If you haven't already signed up, you can find the link on our website, devsecon.com. And by joining the German Deutsch DevSecOn discussion. If you're listening to this session after the live recording, you can still ask your questions on Discord, and we'll aim to get them answered as well with our speaker. Once the session is over, you'll be able to rewatch it possibly in our website and share it with friends and colleagues, or hopefully both.
Perfect. So DevSecCon is brought to you by Sneak, and our aim is to create a vendor-neutral space to share knowledge and best practices related to application security. With that, that's enough from us. Without further ado, we pass over to Rex. So welcome to DevSecCon, and
Thank you, guys.
stage is yours.
My name is Regina, but everyone calls me Rex because it's a long name and really, really hard to pronounce. I'm a DevOps engineer and tech lead currently working with Tansa Industry Solutions for 5 years now, 3 months, 2 days, and 4 hours. But who is counting? And I've been working a lot of support in the IT area. I started as support, as a DevOps tech lead. I also done some development, so I've done everything. And I'm currently now working what I enjoy more and what is way more interesting and exciting. I'm based in Tirana in Albania, and the weather is really way better here.
Hopefully.
I'll vouch for that, yeah.
Fantastic. Rex, I'll pass the screen share to you, and we're just going to hide ourselves.
Yep, thank you. Okay, so for today, we're going to have a presentation about the evaluation of security within a Go-centric DevOps environment. This is done from my perspective as a DevOps engineer and how it is way better to implement security in a DevOps environment and to keep our environments safe and sound. So this is mainly like an explanation of why we need a security in our environment, because you have the support team, you have the sysadmins, you have the developers, you have the DevOps, but they all create this kind of application, this all kind of services, all these environments that we need to have. But not many people take a look at security that much often, except for the security team. But it is way better and better practice that we need to implement security in a way and have a better approach to it. And that's why I've chosen the Go. Go is like a friendly DevOps language. We don't have to go with an assembly and building the system by hand. And Go provides a lot of frameworks, good frameworks that are updated and maintained by developers and of course the DevOps, and we can have an overview about why we need Go and its own frameworks for security part. So every this kind of things I mentioned, the support team, sysadmins, developers, or the QA team maybe needs to test their own stuff. We need to create an environment that is safe for them, and of course to be maintained and keep it availability 24/7. So the agenda for today is you're going to have an overview of DevOps, what is DevOps, and the security and their own connections principles. And we are going to go next with security challenges. What kind of challenges do we as a DevOps face on it, and the strategies of evaluating for security. So maybe to explore an effective methods on what kind of tools do we mainly use, and how to enhance it to make it way special and better environment. And of course, last but not least, I'd like to call this as a cake or a candy in the end, is the best practices and tools. How we actually work, and not to just read from a presentation or to read from good documentation on open source, but to actually go practice on it. So the definition of a DevOps, you can also say that DevOps is between the dev and operations. So we actually develop stuff, but we also operate on it and we maintain it. And this is how the DevOps link or the DevOps trend came on. But as you know, developers and IT operations, they are not well too familiar with security, and that's why we need the DevSecOps and how the security is really needed in the DevOps link or in the DevOps processes. So for some people will say, okay, DevOps is just CI/CD releases, and you could just do your job and it's over. But actually, no, it is way more difficult than this guy on the GIF that's throwing his own PC. Uh, but we need to take care a lot of breaches, downtimes, the risks that there are over in our environments, and of course to have a life cycle into it. So we build an application on the CI, we test it, we do some analysis, a lot of checks, and we release it. And of course, the environment needs to be safe when the application is going to go. And of course, why Go is way better in this kind of cases, it is because of the complexities, which is like a Go-centric. So every module or every library will be connected to one specific node and it will be shared to others. So you don't need to take a module step by step or every module for every file. So for this way, the Go has chosen to be created in a Go-centric. It is a safer and a better practice to use. So we have secure coding, which they are like put validation, error handling, and proper use of cryptographic libraries, which we are going to cover all of those. But this is really important because on the input validation, for example, on the input validation, a user will enter some comma or some weird text on the first name. Enter, or maybe they can use some injections on the tables. So that's why we need to use input validation, because we check what the users or the attackers put into our system, and we validate on them whether it is able or it is not able. If it is able, then go proceed with the other processes that is in our application. If not, okay, let's stop at the beginning. We don't need to go you anywhere because we are not safe for us. Error handling, of course, as a developer, and every developer need to take a handling of the errors way better approach, because if you see an error and you say just 400 without no explanation or without no error codes, then it is not worth it. You don't even know what kind of error you have had until you go and take an analysis, and we should take a lot of time. So error handling is a better approach for DevOps, security, and the developers team. And last is the proper use of cryptographic libraries, which they need to be with encrypted and decrypted. So this is a difficult process in every environment, in every process, in every programming language that is doable, but that's why Golang come in hand is with its own framework with encryption. So we encrypt the data and we decrypt the data as soon as we get a connection, or in other way, or in other words, as soon as we get a yes or a token limit into it, which all of this we're going to cover in the next slides. Uh, for the strategies for evaluating security, as I said in the beginning, is the CI/CD, security testing, audits, and threat modeling and AI. I know that you've heard a lot about the all of these strategies, but in Golang these are really special because you can create a CI/CD in Go and use it for every YAML file in your environment, security testing with tools and frameworks, audits. We all know what is audits. If you cannot handle the audits, then you should go somewhere else. And of course, threat modeling and AI. But this is really cool and really a nice, interesting way for us to identify potential security and, of course, to prioritize mitigations on every case or every scenario that we are going to face or for any errors. The first one is for the CI/CD. This is a really important part for every environment, for every application, because CI/CD is a life cycle. You build and deploy. But how do you build and deploy? So on the CI part, we have a different perspective as a DevOps and with DevSecOps. On the CI, we need to check everything of testing for security testing, if the application is available or not, what what module is missing on that, what kind of file is missing, or if it maintainable or not. On the CI part, as a DevOps, it is really important that we do these checks before we build the application. Because if you build a secure application into your environment, then it's not worth it because no one has tested it. You have an old library from 2006, and every security or every beginner in security will have it easier for your environment to hack on it. So that's why CI/CD is one of the critical points for DevOps to play around with. But of course, we have other tools, which is Sneak and a lot of other frameworks, which provide us some security testing and security analysis for vulnerabilities. I've personally actually worked a lot with on the CI security part, and it is a way better to use at least a security check in your CI part because it is maintainable. It is one task, which is let's say maybe 6 lines of code, and it's as a crucial part for you to build an application. And I also have made an let's say a practice on how we actually use on the release on the CI part. So this is a typical YAML file that we have on in every application on every environment. So as you can see here, first of all, we need to choose the agent. The agent it can be any, or if you like Linux, or if you are like me on a Windows, you have to go with Windows, but I preferably chose Linux. But you can use whatever environment is available to you because these kind of checks and all this kind of dependencies are available and they can be run anywhere. And you can choose the environment that you want to go with. And these are the stages, as you can see here. All we do, we say to the agent, hey, before when you go to the environment, I need to do these checks. I need you to do these checks for me. So I need you to prepare an environment for me, and we create an environment where we install all the dependencies. We build the application, we run it, the unit test, whether the developer has written the test or not. We can make some quality gate over here, which in this case we have not because it's a demo. And but it's really important that we add a quality gate. Quality gate, I mean with the if the testing has not passed over 30% or 60%, which is mandatory, then do not go anywhere, fail, close it right there where you are, do not do anything, and goodbye. But if it is okay, the developers or the guy building the application has done this kind of testing, then we go to the next step, which is security check, which is really, really important. And that's why Golang is way better for this. We can use the Go-sec framework. So we can run the static code analysis right away with the Go-sec library, which is available or is open source. So you have to take a use and you have to take this kind of cases from open sources. That's why we have GoSec. What GoSec does, it checks all the files that you have in your application, for Go files in this case, or maybe if you have a C# application, you can also make some modifications for it. But of course, with a GoSec, you can check for every module, every library, every dependency, every graph that you have on your module. Because I, as a developer, I just get a module, right? But I do not check what's behind that module, whether it has some connections with other old modules or whether it has some problems on bugs in that modules. That someone on the internet, open source, like had the idea and just push it around. So that's why we need to use the GoSec library, because it does a thoroughly checks and security analysis of course static code. But it's a good thing that we use this in security check in our CI part. And if everything goes well, security checks, which is some DevOps will set it as critical, or some DevOps engineers will set it as a high critical, um, let's say, attribute on your CI part, which most of the time it will pass if you are updated, if you have upgraded your packages, then you're good to go. There is no problem here. But if there is only one library that is old and deprecated, it will fail right away. But if not, then we go with the code quality. So there are a lot of checks for every application there to be done, because these are like uh, must to do. With the code quality, you can use the linting. The linting is a process when we check if there is any white spaces, or if there is any code quality smells, or if there is any issue from your application. That's why we go to linting with better formatting, and every developer, QA, and DevOps will check the mess that there is in application. With the Go linting, it fixes all of them, and it'll give you an overview at the end in the terminal and why it failed. But with the GovVet is just another God quality that we use for quality checks. For example, if you have something missing, or you have used an empty function, or on your function it is not especially routed for whatever implementation we wanted to do. I'm going to give you an example how I was able to work with handlers, and when I used the GovVet, it failed right. It failed right away. So when I got the function for this, the get pipeline, and I did not use any response on this, because I was lazy. I didn't have time, and I was just, okay, let me put this one. If it is an error, make it for a 4. But if you get the 4 what do you get from it? You do not understand what kind of error you're having, what kind of issues you are having, and why the hell it is failing. And that's why we use the govvet command into the RCI part for code quality, because it's a better approach for everyone, even for the users, real life users, to handle this kind of issues. And if everything goes well, all you have to do is the artifacts is almost the last step. When we get the application after we have done every checks on our part, and we put it in artifact, or if we put it in an image, and we box it, we save it, and it is good to go. And we save it in our own directory where the agent is. And after all these checks are done, Okay, then we will say to the agent, you know what? It's perfect. It's okay for me. Deploy it. And it is finished. In this case, the CI is done and completed. After all these checks, every developer that I've worked with really hate this kind of checks because they think, okay, why is it taking too long for me to build an application? Okay, you can still build an application, but it will be unsafe for the environment, if for the production, dev, or test QA environment. In your machine, you can do whatever you want, but in our environment, we have these checks and these restrictions to do. So after everything is finished, we will go directly with deploy. And we can use the Kubernetes uh, commands, which is the kubectl, when we will create a deployment.yaml file, which is most of the times already made by Kubernetes itself. And we can save it as a container, instance running, or a container app into our Kubernetes environment. And after Kubernetes has done its own running in the container apps, Kubernetes is just an orchestrator. It gets the container from the sea, a lost container in the sea, and it pushes somewhere in a row in a control way. And of course, it's safe. It's not like a huge container from Amber Suit that will throw somewhere itself. And after everything is done, some companies or some individuals will like some approvals, which of course makes sense because I don't. No one wants to have an intern on your company making deployment and without any approvals into production environment. That's why we use this kind of approval, where some of them will be manual or some of them will be automatic. A best approach is to be manual, and only the responsible people, which are going to be PMs and POs of the applications, will be able to approve it after they have done all the testing needed, even by with our checks from the beginning that we did NCI. If everything is green, then they can manually approve it. And everything is done, we want to keep the agent as free as possible. So the agent is always running, always running in your environment. But when you have 1,000 microservices, for example, and the agent is exhausted, is fed up, is uh, is is having on the worst state ever, then you have done something wrong on your on your CI/CD. You are not cleaning it up. You are not cleaning the mess that you have created, because as you saw in the CI, you had a lot of checks, a lot of frameworks, a lot of responses on your terminal. Okay, and after that, you went to to the deployment. It's still waiting. Every 5 minutes on the approval, for example, it is writing terminal, writing every time. But they get saved in the agents cache, which they will be in the memory L1. But of course, every environment is different. In Windows, for example, it is a worst case scenario to not use a cleanup because even if you open Google, it will crash. But if, for example, if you use in a Linux environment, we need to use the cleanup. Of course, we say this always because we need to keep it as feasible as possible. So it is okay and good to go. So this is for the CI/CD. It is really interesting and a really better to work with the CI/CD as a DevOps as you are. But of course, this is a key point that we have on the on our strategies. And the next part is the security testing. So we have the secure static account analysis and dynamic analysis for security part. So it depends what kind of issues or what kind of responsibilities you have in your own company or individual. Uh, we have a lot of tools out there, open source or even with the paid versions. which provide us this kind of analysis for security vulnerabilities, code error, code quality, code smells, bugs, issues, and fix. But the most important part is you must have a security check, as we did have in our release.yaml file. And yeah, is the audits. Audits are the most crucial part for every PM and every business guy. Or if someone is lying, okay, if you do not believe him, go to audits. Everything is written in the audits. Everything is saved in the audits. So every issues, every problems that might come from the history, everything is in the audits. So everyone can check, everyone can read about all the issues that they are having, and just get the audits, and it's finished. The audits is only the truth. Of course, it is like code reviews, security flaws, design flaws, implementation errors. They are everywhere. That's why we need the audits, because of the if you use VCS, for example, GitHub. If you use a Git repository, you can see the Git name and the Git history. Whoever has made the commit or whoever has created this kind of issues, you can see right away how to revert those, which is a crucial part of the audits, and of course to make a hotfix of that specific commit, which is doable. And that's why it is really important that we keep the audits in our VCS or code base or in our infrastructure. So, but of course, not only this is one of the examples that I gave as on a developer's perspective, but if you are an sysadmins or an NetOps working on infrastructure, or DevOps working in infrastructure, you can see right away the event logs, every logs of dedications or vulnerabilities that the container of the image is having. This is really good because they help a lot to ensure the application is secure, it is maintainable, and it is running 24/7, at least. Of course, no one can handle the truth. There is no one that can handle the truth from audits. Everything is saved there. Of course, we have the threat modeling and AI. As I said, it's kind of a candy, or how it involves a lot of prioritizations of security threats, vulnerabilities, and attack vectors in every software. I'm going to give you an example on this. If you have a dependencies of or null dependency or a deprecated library in your application, what what do you do? Do you have to go in every file to check that, or you can use a trick, which has been implemented lately in the 2 or 3 last years, which is the threat modeling and AI. These kind of tools, this kind of threat modeling and AI, like Dependabot on GitHub or Bitbucket, has some sort of merging comes, but of course Sneak also is really good on it. That will give you a pull request on your branch, on your application, on your repository to upgrade that dependency. So they do all the analysis itself on the packages, on the files where they are saved, and they are able to upgrade the dependency by them, all by them. And all you have to do is just one click, approve their pull request from the robot, and it's finished. A good thing about this is that it's 24/7. The dependent bot, as soon as there is a vulnerability or the CVE has been shared online, the AI will track that and check your application if you have that or not. But if you have it, it will make all the analysis of your application where this module is saved and has been written into it, and it will make suggestions and will give you some possibilities to upgrade those kind of dependencies. This is a really a candy, I would say, for the DevOps world, that we have to use. We use this a lot lately. Best practices. We have secure coding guidelines, which of course every developer has it in our mind to use secure coding before we finish a product, finish an application. To utilize secure package management, implementing MFA, encrypting the data, log data, vaults, secret, and token limits. I'm going to give you a step-by-step example, so I don't want to mess up with you a lot of things that we are showing for today. But they're really really easy. They look like they're really difficult or no utilizing, but it's way easier than what you think. For example, secure coding guidelines. For secure coding guidelines, you can use the input validations, which is really important. You can use the encryptions, error handling, and cryptographic. So in Golang, it is really easy, and it helps us a lot that we get the input validation. I gave an example at the beginning. When a user makes an injection into our table or into our first name of a table, that's why it is really important to have this kind of validation. What things a user puts into application, because every DOS attacks, every issues, every attacks happen because of these validations. If you do not have any validation in your uh, in your code, then what are you doing? It's not worth it. Put some validation into it. The user is sometimes is the smartest it is the smartest hacker, or even the dumb user or the Guinea pig will take a look at into it and crash the application. But of course, you need to make this as a priority. These secure coding guidelines. But of course, you have the encryption, which we need to have the encryption everywhere into sensitive data like passwords or personal data. Some companies will like to use the personal ID. They need to be saved, and that's where Golang comes in hand. We encrypt the data, but we also decrypt it as soon as we get the confirmation the key is correct. And that's why we have other libraries with a GoCrypt framework, which is really popular, and really easy to use into our environment. Utilizing secure package management tools, or the famous apt get update. That's it. Uh, I'm in Linux. As soon as you open your PC, you have the options to update your packages, your modules automatically, or as soon as you need to install a library, install an application, you need to update all your modules or all your libraries. So that's why Linux is one of the safest environments over there. But of course, no one has the privilege to work on Linux. So other people will work also in Windows. But that's a really easy thing for Golang, because we can use this package management tools like Go modules and GoDep. If you use the GoDep, it will give you all the dependencies and all of kind of packages management that you need to have and to keep it running. Everything that you run an application, or every day that the container is rising. But of course, the best idea is to keep this always up to date with the LTS version, not the latest version, because no one is testing it. But of course, not the oldest one because it's deprecated. But the LTS version, the stable version, is the best approach to have in your dependencies in of your environment. And the MFA, or multi-factor authentication, is another extra layer for your environment to be safe. So you have done all of this. Uh, Security checks, got depth, got links, got code quality of your application. You have got an updated environment, but do not forget MFA, because MFA is really important. By your own personal device or even from your own smartphone, you can connect with Microsoft Authenticator, Google Authenticator, or whatever authenticator there is for free is a good way. Just scan the code, get your authenticator and OTP, because even hackers or attackers are able to pass all of these other factors that we mentioned before. But as soon as you get an MFA, it is only you and your device that has the personal password, or sometimes it's like 6 lines of code, or sometimes it's 10. It depends on how you will be able to get the validation and how you put it over there. But this is a really great way and the best approach that we keep the MFA, the smart cards and tokens and one-time passwords. The next one is for the encrypting sensitive data. Uh, we all know for the encryption, but it is really important and really easy to mitigate this kind of issues if you are not using a secure encryption into your environment. Every data that you need to get into your application, you need to have it at least safe somewhere with encryption. You cannot have any sensitive data at rest and in transit without any security. So you need all this kind of securities and protocols. Other protocols are HTTPS and TLS, which of course there are encryptions and other protocols, so we can be safe and secure. And the importance of this is that if we encrypt all this sensitive data, no attackers or any issue with arise or data breaches. If there's data breach, if the data is encrypted, you need a key for it. And who has the key? Only you have the key, the user. Yeah, that's why it's really important to have encryption set up in your environment. And we have tools for security evaluation, which, as we said earlier, we have the GoSec, Sneak, or SonarCube, which they are really helpful for providing us security vulnerabilities for checks. There is also another one from GitHub, which is free, everyone can use it, is Dependabot, which lately, with the help of an AI, has been way more helpful than what we need. But these tools are really important and for us to keep in our environments and in our application, because they do all the static analysis checks and or dynamic analysis checks. And it's good to have, it's good to be aware of your application, it's great to be aware of your environments, what your environment is having, or what kind of issues there is there, or a CVE is online, but who is checking all the CVEs nowadays? Only the AI. But of course, we have an important part, which is the container security tools. You can use the Docker Bench, which is an extension of the Docker, and will give you all the issues for security side of your image. For example, if your container has a deprecated image or not running image, Docker Bench will ping you and send you notifications or will alarm you for all of these security issues that you have. And you have the possibility to make this Docker bench as a check in a CD part. For example, if the check is not successful, then revert the image back where it is okay to go. This is really important. And I've seen a lot of people and a lot of DevOps using this. So it's a really great approach that you also use Docker Bench on your container. Okay, more tools. You will have the security for security evaluation. As I said, dynamic analysis and static analysis. This a really great way to have in your CI/CD, because there are 3 lines of codes, as you saw earlier, and but they are really helpful for you to check any small step, because every small step is really important because every attacker wants the small steps, and that's why we need all these kind of security evaluations tools. And of course, if you are working in the sysadmins side or third level, some people will say it, you have the web application firewalls or WAFs. They are really common now because it's been like 10 years. Everyone is working with WAFs, with the firewalls, and it's a really nice way to monitor your application and to filter the incoming traffic. Because there are some countries or there is an IP pinging your website 100 per second. Okay, who is this guy? Why does he want to ping it? Does he want to test us, or maybe he's trying to attack us? So that's why we need this kind of WAFs so we can monitor every step that we have over there. Uh, I also, yep, I also have made some, let's say, some examples how we use for all this kind of encryption and security tools. We shared about the CI/CD, the release.yml, but it's a good approach that we also keep the CI/CDs created. For example, we have the most used command, which is the run command. All these commands will do, it will take the pipeline and it will run it from the agent. It will check the agent who is running or not, and what kind of commands we have in our YAML file. And of course, you need a response, you need an output. That's why we use the run command with output function, so we can get the buffer, and from the buffer we get the output, and we get the response saved in our terminal, and or maybe we can make a trick and save it into our in a text file. Okay, yeah, this is just a checking command exists. If the other command that we have over here, you have put in the terminal already exists, okay, check the file. If it is over there, then execute. If not, then give a response an error in this case. And as you saw from the presentation, we have the handling errors, which is important to have it because input validation, or if there's any issues, just handle the errors. There is a must to have these kind of functions in your SSD to handle all the errors. For example, you can make a mistake. Instead of sudo, you can write the sudo, but you will not get it once you write it because you did not handle it. So that's why you need to handle this kind of errors and this kind of comments into your CI/CD. And in other hand, we have the DB for the database connection into our, let's say, organization. Well, it is way easier with Go because we can use the module library, and you can see right away how easy it is to create a pipeline in our database, saved with the name and description, or text and ID. Okay, ID is primary key, but this will be auto incremented itself. And you have the name and description that we can set them up, which is a really nice way and really cool way. And after everything is done, after the table has been created, we can close the DB because, okay, we do not need it anymore. And of course, we need to initialize it, and we give the pipelines the name of the table, or if it is not, if it is fatal, if we have many issues, then we will get an error back because we have handled the error well in this case. And the other file is the encryption. As I said before, we have all type of encryption, which is the AES, HTTPS, TLS. But in this case, we have put the handler of the sensitive data is with the AES algorithm, and all it does is just take a library itself. So there is no problem anymore. It's good to go. The data is encrypted, as you put here the sensitive data, and it will be saved in the encrypt data. And after it is saved in the encrypt data, then we get the data there and we put it into a byte. So we get the data sensitive underlying data, and we encrypt it. This encryption will be in a 16 bytes of secret keys. So it's a really hexadecimal key that you will be safe for this kind of encryption. And everything goes well. We have handled this error really well, encrypted successfully. Okay, yeah, of course, as handlers, we always try to handle it, all kind of function, all kind of issues that we have in our hand. So for this case, there is just a database that we created before for the CI/CD. We got a database, and now we are trying to handle it. So, for example, if you get a pipeline, then you will get all the data that you need. But if not, then you can get right away with an error, which is will be an invalid pipeline ID, or a bad request in this case, which usually is a 400 status code. And after all that is done successfully, if you get in a pipeline from our database and it does not exist, we also had the option as we created in this sd.go to create that pipeline. And if we got into this function to create a pipeline, then we do a query, a simple query, when we get all the name and description and the values into our database. So everything will be saved here. And of course, we have handled this in internal server error, which is great because if we use the HTTP module, it will give us a response directly made from uh, uh, our GOM module that we have checked. And of course, it is a CRUD. We have get, and we have created it so far, and we have now to update it. This is the best approach that we update it. A lot of DevOps have its own alternative. Some people will take another look, or maybe they just go to Postman and do it manually. But why do that manually when you have the option to do it right away with a CRUD operations in Golang? So that's why you can get all the ID and the parameters that you want to update it. So we need the name, description, and ID, because ID is primary key, and the name as we set it, and the description. After we have put them all successfully, we will be able to update them in a CRUD operation. Last but not least, I mentioned CRUD, create, read, update, and we are at the delete function. With the delete, it's easy, just a query. Delete from pipelines where the primary key, in this case, is ID equal to 1, for example. And this is finished. We have also done the login handler in this case, which is just for the if it is not successful or if it is not, to authenticate into our own database. So that's it. But we also talked a lot about sec testing, but in Golang it's easy. All you have to do is to use the framework Go-sec, and it's finished. It's done, it's okay, and it's good to go. It will, as I said before in this SED note, with the Go-sec, you are able to check all the files, all the module, all the libraries that there are there that have issues, and of course, DebGuard. It will check and it will give you an overview of all your dependencies that have linked with each other, because you have a module, for example, and that module is saved in the file, but as a developer, we do not care what kind of modules we have created. We just get the module and push it there. It works, okay, perfect. But behind of it, that module has a connection with the CVE that is shared online now. And that's why DebGuard comes in help, because it checks step by step, one until the end, where the files and all the modules are saved into our packages. And from the sec testing with the Golang, is done, is finished. And of course, we also done the MFA. This is an approach. I mean, if you will use the Microsoft that is out there, it's easy. Just next, 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 and it's finished. But you are DevOps. Come on, you are able to create one for yourself. So you first of all you need to do is just to use the TOTP module, which is open source, anyone can use it, and it's really helpful for a lot of applications and a lot of DevOps using it. So we retrieve the key. The parameter in this case will be just the username. So we get the username and we save in the secret key. And after all the MFA secret key is finished, all we have to do now is just to return it, to return the key, and we are able to access it. So we return the key, okay, we return it, but also not verify. So that's why the verify and the code come in handy with a secret key. So the secret key now makes the checks of the library that we have here, TOTP. This one is from that, and now we use the username and we make connection with the secret key that we got. Are they correct or not? If they are, okay, you are able to go in. If not, then you get an invalid NFA code. Then we do not know who you are and we close the connection right away. Okay. Da-da-da-da-da-da. So we also saw to share this. Okay. So this is the conclusion. So what we have learned about so far, maybe to the most important part or a must, I would say, is to integrate security into your DevOps world, into your environment, not only for DevOps, but also for your other teams to check the security. And this is the helps that we did today for the CI/CD pipelines, automated security testing, the tools that are there, even open source, and to check the code review, code quality checks, code smells, security audits, and of course, the threat modeling and AI as we did to have into our application and infrastructure. Okay, so references for this kind of presentation on of the slides was from Medium, Google Links, and someone who had an idea from the internet, but we forgot his name. Yeah, it's a joke, not real, but and GitHub, it's for my own personal GitHub that I post a lot of projects since when I was a university kid, and when I'm a bit free, I publish something there. So you can also check the GitHub and take a look at yourself for every repository of the application that you might be interested in. So yeah, I think that we are finished. Yeah, we are finished for the slides. Okay, hopefully it was a best approach ever. It was a bit easy. I did not mess it up.
Thank you, Rex. First of all, really amazing. Actually, to replay our community members that had a comment, so we had on YouTube. So amazing.
Okay.
Thank you. Really well done.
Thanks.
So just one or two questions from us before we close. Something that I had, more generically speaking, is what is the typical pushback that you get from developers that where you try to instill some sort of security mindset? What does a Go developer say? Like, what would be the common arguments?
Most of the Go developers, because Go is like a really easy syntax language, most of the Go developers will say, "Oh my God, 20 minutes for checks or 20 minutes for checks. Why?" So they really hate the security checks and security testing and every testing and checks that is for the application. So they'll say, "But why waste time? It works on my machine." Okay, but we do not know what kind of module, what kind of environment your machine is, or what kind of dependency your machine is. We have our own restrictions, our own rules. So you have to do you have to play by our book. So you
Okay.
have to wait for the CI/CD to finish, and then you're free to go.
All right. Got it. Adit?
Yep. Thank you, Rex. Really amazing presentation, very informational content, and yeah, great job.
Yep, thank you.
My question was regarding false positives.
Mhm.
Have you noticed a high rate of any like of false positives? And if yes or no, like is there a more practical way to deal with them, or like what's the approach? What would you
Yeah, of
suggest?
course. There will be a lot of false positive because some checks will say you okay, this is this is an issue, this is vulnerability, but in other checks it will say it works for me. That's fine. It's good to go. So that's a best approach and best way to have more than one testing. So if you saw in our CI part, we have way more than one check. We have the govern, golin, debguard, and gosec. So every step is really crucial for us to make some checks. So we cannot trust one application, one tool, one open source framework. We have to make our own services and our own checks and then steps before we build an application first, because there will be a lot of false positive. Not every application or open source tool is the perfect. So
Yeah.
that's why it's a good thing that we make some testing and checks, as you saw in the release.yaml file that we had.
Yeah.
Also,
Thank you. No. Great.
let it all complete one big picture.
Yeah.
Okay. Fantastic. So, Rex, thank you again. Huge thanks. It was great to have you on the session. We hope everyone else also enjoyed the session as much as we did. Rex, you have another comment?
Yeah, I just wanted to thank Ardit. Ardit, thanks a lot. Not only as a friend, a colleague, a mentor. I learned a lot from Ardit. Ardit is
Thank you. Same for
one
me.
of the best guys and best colleagues that we ever had. Unfortunately, he left. But he's a really good mentor. And my Wilbur, maybe he might be watching, or maybe it's another meeting, because he gave me permission to share this kind of slides and to access to be here with you guys.
Great. No,
And
thank
he
you.
also
Appreciate
helped me with the presentation and gave his feedback into it. Yeah, that's all I had. Thanks.
Thank you.
Fantastic.
Likewise. Thank you, Gino, for everything. And yeah, as you said, it was amazing on like every collaboration we had together, and like
Yeah.
you can tell by the presentation you had. And yeah, huge thank you to you and to Seb for obviously organizing this and making this
Yep.
happen.
Thank you, Seb.
Thank you a lot. And yeah, we look forward to future collaboration and hopefully soon.
Yep.
Yep.
Sounds good. So for anyone else listening, please drop over to Discord. If you have any further questions, you get in touch with us. We get in touch with Rex. Also, please share the video with anyone else who might be interested. We are now on YouTube. We have recordings and so on. And yeah, that's it. Thank you very much.
Thank you, guys.
Yep. Thank
Bye-bye.
you.
Bye bye.
Bye.